Hey guys, today we're going to talk about functions in linear equations. A function can be described as a relationship between a set of inputs and a set of outputs. So we put something in, we work with the function, and then we get something out. In a function, outputs have only one input. That's very important. Linear equation is a relationship between two variables where one depends upon the other. And we talked about that a little bit in class when we were talking about the x and y variables and independent and dependent variables on the Cartesian plane. Slope-intercept form is the equation of a straight line, and we can express that as y equals mx plus b. We've seen that before. And then the y-intercept is where your line crosses the y-axis. The x value in that case will always be 0. So the y-intercept is going to be a coordinate. Alright, so let's look at a function. Okay, this is the slope-intercept form. This is our basic linear equation. You will be using this quite a bit, not only this year, but in years to come. We have our x and y coordinates. Okay? Now, most of the time, we don't know what our coordinates are. We'll just be given this equation, and we can pick our own x values. And then if we know the slope, we can operate the x value with the slope, and then our y-intercept. So we know how to find slope, okay, and slope will always be the number connected to the x. Always be the number connected to the x value. And then this b will represent the y-intercept. So once we have that information, we can put in our x value, and that will give us our output, our y value. All right, let's take a look at an example. Okay, so here we have this function y equals 2x. So 2x is going to be our function. Okay, and what we need to do is we need to figure out some points given that function, given that linear equation of y equals 2x. So what I did here was I set up what's called a T-chart. I don't know why it's called a T-chart. I know it looks more like an H or a old-time football goal, but this is called a T-chart. And what we do is we put our x value on the left side. In the middle, we put our function, and then on the right side, we put our y's. So in this case, our x's are going to be our inputs. Our outputs are going to be our y's. And what we're going to do is we are going to operate with our function and the x values. And with these functions, we get to choose our points. And if I can give you a little hint, I would choose very easy numbers. You can see I've chosen -1, 0, and 1. And because the easy numbers will get us our line, okay? And we don't have to worry about not fitting on the page or something like that. So what we're going to do is we're going to take our first x, our first input, and multiply that by multiply the -1 by 2. So we're going to take 2 times -1 would leave us with -2. Take our second input, 2 times 0, which is 0, and then 1 times 2, which is 2. And that will leave us, this will actually help us derive our coordinates. So we have -1, -2, 0, 0, and then 1, 2. So we can come over here and graph that. So we have, let's see, -1, -2, and then 0, 0, and then 1, 2. And we have a straight line, and make that straight, and we can graph that, and there's our line. That is graphing y equals 2x. Our next example is y equals x plus 4. So again, I'm going to choose my x values. I'm going to choose something very simple like -1, 0, and 1. So I'm going to put those into our equation, replacing or substituting x for our in our function, and that will give me the output y's over here. So we put in -1 and add 4 and we get 3. We put in 0 and we add 4, we get 4. And we put in 1 and we add 4 and we get 5. And that will leave us with our points -1, 3, 0, 4, and 1, 5. So let's go ahead and plot these. So -1, 1, 2, 3, and 0, 1, 2, 3, 4, and 1, 5. And there's our 3 coordinates plotted. We can draw our line. And there we go. Now, as a hint, I would always include 0 as one of your options for your inputs, your x's, because that is always going to give you the slope or the y-intercept. Okay? Remember that we said that the y-intercept, the x will always be 0. Well, here is 0, and here is our y-intercept right there. So it's going to cross the y-axis at 0, 4. We can see that. So 0 is always a good number to choose for your x inputs. All right, let's look at one last example. This one's a little different. In this case, we have y is equal to -1/2 x plus 1. Okay, so I'm going to set up my x and my y values here, and then I'm going to operate with my x values in my function. So -1/2 times -2, so negative times a negative is a positive, and then 1/2 of 2 is 1. So I have +1 plus 1, which leaves me with 2. Then I put my 0 in, so 0 times anything is 0. So plus 1 is 1. And then I put my 2 in, so -1/2 times 2, so negative times a negative times a positive is a negative, and then 1/2 of 2 is 1, so I have -1 plus 1, which leaves me with 0. So my coordinates are -2, 2, 0, 1, and then 2, 0. So let's go ahead and plot this. So we have -2, 2, 0, 1, and then 2, 0. So there's my line. You can see that this slope is negative, which is different from my other slopes, which were positive. And I'm going to draw my line here. Okay, so there's my line plotted. You can see that my line crosses the y-axis at 0, 1. Again, that's why I chose 0, 0, 1. Gives me my y-intercept. And that is our line, and we are done with it. So we're going to be doing a lot of work with this in class, and I will see you there. Oos!